Welcome, dear students. Welcome to the YouTube channel of Department of Public Health Dentistry from Chettinad Dental College and Research Institute. I'm Dr. H. Cyril Benedict, here to start with the types of data in biostatistics. Basically, there are two major types of data. Okay, so there are some subtypes, but these are the two major types. The first thing is quantitative and qualitative. I'll teach you what is quantitative first. Okay. I'll teach you what is qualitative first. So after learning what is qualitative and quantitative, you can group these things under the two major types. The first is qualitative. Quality is anything that has a quality to it. Qualitative data is anything that has a quality or anything that is being categorized. That is why qualitative data is also called as categorical data. Okay. So, for example, type of blood group, nationality, and gender, all these are qualitative data because there is a quality to it. Gender types means based on the sex. Nationality means based upon where you have been born, the quality of your birth. Okay. So, this qualitative data is further divided into nominal and ordinal. Nominal, norm means name. Okay. Any data that has just category, that has just names that are just represented by a category or a name is called as nominal data. For example, ABO blood group system, gender, nationality, what else? Color of your shirt or your mobile model or mobile brand. Okay. See, in all these things, they are mutually exclusive. They are mutually exclusive to each other. Okay. For example, in ABO blood group system, there is A, B, there is O, there is AB. So one of the blood group is not superior or not inferior to other. Okay. They are all same. For example, gender male and female, there is no inherent superiority or inferiority between them. If you want to ask about nationality also, there is no inherent superiority or inferiority among this. They are just names. Okay. All the data points in each are mutually exclusive to each other. That is what is called as nominal data. Whereas in an ordinal data, there is an inherent order in it. That is why it is called as ordinal. Odd means order. So ordinal data. Ordinal data has an inherent order in it. For example, severity of a disease, socio-economic status. Third, I can tell BMI. BMI, when it is being categorized, I can tell it as ordinal data. What is this ordinal data? There is an inherent superiority or inferiority in it. For example, severity of anemia, mild moderate, severe. See, mild grade anemia, moderate anemia, severe. For example, less than 11 is mild, less than 10 is moderate, or less than 9 is moderate, less than 7 or 8 is severe. So, as the list goes from mild to moderate, the severity of anemia increases. Can you understand that? There is an inherent order, that is mild means the anemia, the hemoglobin level is only slightly less. Moderate means moderately less. In severe means very much less. So there is this inherent order. Socioeconomic status: lower class, upper lower class, lower middle, upper middle, and upper class. As you can see, there is an inherent increase in socioeconomic status, the salary or the education, from lower class to upper class. When you take two levels here, for example, when you can take upper class versus lower middle, or upper class versus upper middle, you can definitely say the socioeconomic status is higher at the last and lower here, and very much lowest in the lower class. Okay, so there is an inherent order. Something is better than other thing. For example, in BMI, underweight, normal, overweight, obese or pre-obese, then obese, class 1, etc. So as you can see, as the BMI class goes from underweight to obese, there is an increase in BMI value. Okay, so the person can be lean here and he can be very fat here. So the BMI or the weight or the trait, the quality that he is being obese is high in obese class 1 and it is not there in underweight. That is, the weight, overweight or being overweight steadily increases from underweight to obese class 1. So there is an inherent order here. There is this inherent order that one of the class, that is, you can tell obese, the BMI is much higher than underweight. Or in the people having overweight will have BMI more than normal and less than obese. It works like that. Okay. So nominal data means just names. Ordinal data means along with being names, there is an hierarchy. There is an order within. This is called as nominal and ordinal data. Coming to discrete and continuous data. Discrete simply means whole numbers. Continuous data means any data that can take decimals or fractions, or it can take these values when a mean or an average number is taken. Usually, guys, this kind of discrete data is mostly not there in our medicine, because anything in medicine, anything in dentistry, or any value in medicine or dentistry, we usually take mean. Okay, when we try to summarize, we usually take mean. So in if you take mean, what you'll do? Add all the values and divided by the number of persons. So usually a mean value will come in decimals or a fraction. No. So, or an improper or mixed fraction. No. So this kind of discrete data is usually not used or referred or summarized in a medical science. So usually, okay. The best example for discrete data is, I can tell, is number of persons in a family. There is only whole numbers. You cannot tell in a family there is 3.5 persons. Okay, you cannot tell in decimal for that. So usually when it is not amenable for summarization or means, we call it as discrete data. Whereas continuous data, remember, for example, imagine weight or height Okay, weight or height. Weight in kilogram or pounds. Height in meters or centimeters or inches or feet. Somebody can be 57.6 kg. Okay, somebody's height can be 172.5 centimeters. That is possible. So when decimals and fractions are possible, it is called as continuous data. For example, BMI. What we do in BMI, weight in kg divided by square of height in meters. So when we do this, we usually get a number, no? Usually, remember the number can be in decimals. For example, 24.9. So again, see, when we take mean, we can get a decimal. So BMI, when it is still a number, it is a quantitative data or a continuous data. But when you try to categorize it, into the BMI scale, Quitlet's scale, for example, 18.5 to 24.9 is considered as normal BMI. Na? So in this case, this is normal. So quantitative data usually can be converted into a qualitative data. So if somebody tells their BMI is 25, you can tell them that they are normal or slightly, okay. If they tell their BMI as 19, you can tell them that they are normal. Whereas that for 19 is quantitative data or continuous data. This can be converted into a qualitative data. The reverse is usually not possible. For example, when somebody comes and tells that his BMI is a normal range, just because looking at him or knowing that normal range value ranges from 18.5 to 24.9, you cannot see the person and tell what is his exact BMI value. Okay, so quantitative to qualitative is possible, whereas the reverse is usually not always possible. So with this, we can end. Summarizing the thing, we have two types of data, quantitative and qualitative. In quantitative, we have discrete, continuous. In qualitative, we have nominal and ordinal. Thank you.